Welcome to our next lesson in fractions, fractions 2. This is a continuation of yesterday's lesson where we learned about how do we turn mixed numbers into improper and improper fractions into mixed numbers, as well as simplifying. So hopefully you used what you learned in yesterday's lesson to help you with these questions on the starter, and we will go through these to begin with. So you were asked here to simplify 27 over 63. We will look at two ways you could do that. Remember I said you always want to try and find that knowing your tables is really important, the biggest number that goes into 27 and 63. So if we went for the biggest number, we would see that 9 goes into 27 and 63. Okay, so 9 goes into 27 3 times, and it goes into 63 7 times. So the answer to that question is 3 over 7. Using 9 as your common factor will get you the answer straight away. Let's just say you didn't see 9 was the biggest number that went in there and picked 3. Let's say you spotted 3 went into here. So 27 over 63 is equal to, how many 3's go into 27? 9. How many 3's go into 63? 21. And from there you should be thinking, I can simplify this again. Does anything go into 9 and 21? Yes. 3. 3 goes into 9 3 times, and 3 goes into 21 7 times. So, even though we picked a smaller factor for this one, we still got the same answer. Okay, we got the same answer, but as you can see, if you can find the biggest factor that goes into the two numbers, numerator and denominator, you get the same answer a lot quicker. So knowing your times tables is really useful. Moving over to the top right, we have been asked to convert this mixed number. So remember, this is a mixed number because it has a whole number and a fraction into an improper fraction. And remember, an improper fraction is a top-heavy one where the top is bigger than the bottom. And to do this, if you recall that we take the denominator, we times it by the numerator, the whole number, and then we add the numerator. So we're going to do 7 times 8 and then add on the 4. Okay, so 7 times 8 is 56, plus the 4 is 60. Over, remember, the little trick is it will always be over the same denominator over 7. So you should have got 60 over 7. The bottom left, it wanted you to write 23 over 14 as a mixed number. To write that as a mixed number, we have to see how many times does 14 go into 23 whole. 14 goes into 23, well, what have we got? We've got 14, 28. 28 is too big, so it's not twice, so it's one whole one over the original 14 left over, and you have to work out what would go here. Well, 1 14 would be 14. How do you get from 14 to 23? You add on 9. So our answer would be 1 and 9/14. Okay. Moving on to the bottom right, you've been asked to simplify again. If I'm going to simplify 24 over 53, we can use the same tricks we looked at last lesson, which is they are both even, so we could half them. So we could say that was 12 over 27, and then realise what goes into 12 and 27. That would be 3. 3 goes into 12 4 times, 3 goes into 27 9 times. So our answer to this one would be 4/9. Alternatively, you could spot that 4/9 could have came from realising that the biggest number that goes into both of these is 6. 6 goes into 24 4 times, and 6 goes into 54 9 times. Okay. Moving on now to multiplying fractions. Multiplying fractions is the easiest operation that we can do with fractions. To multiply a fraction, all you have to do is multiply the numerator by the numerator and the denominator by the denominator. So we can see here, if I do 2 times 1, I get 2 over 3 times 6, which gives me 18. And you should always try and simplify your fractions. Here we can see that 2 goes into both 2 and 18, so we could get 1/9. And there is a way that we can cross-cancel these fractions, which we will talk about in a minute to get this answer quicker. But for now, just knowing that to multiply fractions, you just times across the top and across the bottom. If you can have a go at doing the same method to this one, and then check if you can simplify your answer, and see if you get the same as what I get. So timesing across, you should have got 2 times 5 is 10, and 3 times 6 is 18. Can we simplify that? Yes, we can. What goes into 10 and 18? 2. We could half top and bottom. Half of 10 would be 5, and half of 18 would be 9. So the answer to that question would be 5/9. Now, if you flip over your sheet of paper, and we'll look at how can we do something called, so if you flip your paper over, we can look at something called cross-cancelling, which is a way where we can get the answer a lot quicker without having to simplify at the end. So how does this work? First thing, you have to be really clear. This only works for multiplying. Okay? It only works for multiplying. So you can't use this technique when you're adding or subtracting. You can only use it when you are multiplying. And how does it work? You look at your original question, and you look at the diagonals, and you ask yourself. So if I look at this 2 and this 6, you ask yourself, can I see a number, a factor, can I cancel these, can I simplify 2 and 6 before I start? Well, what goes into 2 and 6? 2. How many times does 2 go into 2? Once. So we can cross off this 2 and put 1. How many times does 2 go into 6? 3. So we can cross off this 6 and put 3. If I check these diagonals, nothing goes into 1 and 3, as opposed to 1, which is pointless because you'd end up the same thing. So we can't cross-cancel these. And this is not a technique that you can use all the time. Sometimes you look at the diagonals and you cannot cross-cancel. Okay, but here we can. We can cross-cancel this and this. Now what we do is the same as what we just did, which is times across. But instead of doing 2 times 1, I'm going to do 1 times 1, which is 1. And instead of doing 3 times 6, I'm going to do 3 times 3, which is 9. And as you can see, I got the same answer, 1/9, by cross-cancelling. Now if you find this a little bit confusing, you don't have to do this. This is just another option. What you can do is just stick to this method where you multiply across, which most students like doing, and then you simplify separately. That is absolutely fine. If that cross-cancelling looks a bit too confusing for you and it's hurting your brain, you can stick to the times across and then simplify again. If we just look at cross-cancelling with this second example, if I check my diagonals, if I check 3 and 5, is there a number that goes into 3 and 5? No. So I cannot cross-cancel that, so they have to stay as 3 and 5. If I check these diagonals, 2 and 6, like we've just seen, yes, we can cross-cancel these. We can see that 2 goes into 2 and 6. So I can cancel this 2. How many 2s go into 2? 1. How many 2s go into 6? 3. Now I can just cross top by top, bottom by bottom, multiply together. 1 times 5 is 5. 3 times 3 is 9. And I got 5 9s. And as you can see, that is exactly the same as what I got over here. I wouldn't say it's as less work for those 2 examples. It's probably the same amount of work. Cross-cancelling can get very, very useful when you're dealing with really big numbers. So these are quite small numbers, so it's not too much of a problem just to multiply across and then simplify. But both methods work. I'll look at some examples where we can cross-multiply down here, cross-cancel. But you can use whichever technique that you feel more confident with. So, you can have a go at practicing. What I would like you to do is I would like you to multiply these across, or cross-cancel if you can, but simplify your answer. So I want the answer simplified as possible. So just like these, we simplified these answers as much as we could. I would like you to do the same. And I will show both versions for number 1. So I'll show how you do it just by multiplying across, and then simplifying, and I'll show how to do the cross-cancelling. So, if we're looking at the first one, if you are just going to multiply across and then cancel, simplify, that's fine. 2 times 1 is 2, 3 times 10 is 30. Can I simplify? Yes. What goes into both 2 and 30? 2. 2 goes into 2 once. 2 goes into 30 15 times. If I was going to look at the cross-cancelling method in blue, check your diagonals. Can I simplify and cancel down 2 and 10? Does anything go into both 2 and 10? Yes. 2. So I could cancel this 2. How many 2s go into 2? 1. How many 2s go into 10? 5. Then check your other diagonals. Anything go into 3 and 1? No. 1 does, but that would be pointless because you'd end up with the same thing. So that's as much cross-cancelling as I can do. Then you multiply across, using your new values. 1 times by 1 is 1. And 3 times by 5 is 15. As you can see, the same answer was found. This blue method was where I used that cross-cancelling skill, and the red method was where I just multiplied across, which most students like doing, and then looked at simplifying it. So hopefully you can work through those. And I will work through them as well in silence, so it gives you an opportunity to practice, and you can look up to see if you got them correct. There are a few of these questions where you can use that blue method, where you can cross-cancel. So if I put a little star next to the ones that you can, if you want to practice the blue method you can. If you want to stick to the red method, absolutely fine. So the ones with a star is where you can cross-cancel, but you don't have to. You can do the other method and simplify. So hopefully you are getting some of the answers that I am. If I'm going a little bit quick, you can always pause and the video will just continue after it's done. This one here simplifies to 4/3 because 10 goes into both 40 and 30. Up here we can cross cancel what goes into 4 and 2. Well, 2 definitely does, so we could say 2 goes into 2 once and 2 goes into 4 twice. I can't cross cancel here because nothing goes into 2 and 3. So we can multiply across with our newfound values. This just stops us having to simplify at the end. 2 times 2 is 4. 3 times 1 is 3. So what you should see with this answer is it's top heavy, and we would like to change that back into a mixed number, because you generally want to give your answers as a mixed number if it's top heavy. How many times does 3 go into 4? Once, with a 3 left over, and we need to work out how many thirds are left over. Well, if 3 goes into 4 once, that would be 3. How do I get to 4? There is 1 left over. So it would be 1 left over. Okay, next one. You should have done 4 times 2 is 8. 3 times 1 is 3. Top heavy again, how many times does 3 go into 8 whole? Well, you've got 3, 6, 9. 9 is too many, so 2 whole ones. With how many do I need to get from 6 to 8? 2 left over. So it's 2 whole ones with 2 over 3 left over. And what I'm doing here is from yesterday's fraction 1 lesson. So if you're unsure, you can go back and look at that. Next one, 4 times 3 is 12. 3 times 1 is 3. Can we simplify this? How many times does 3 go into 12? 4 whole ones. The answer with nothing left over. And finally, if we look at the cross-cancelling method here, we can see that 4 and 4 What goes into both of those? Well, 4 goes into that once, and 4 goes into 4 once. And the same with these 3s. 3, 3, both can fit 3 into it, so that would be 1, and that would be 1. So this essentially is 1 times 1, and 1 times 1, so 1 over 1, which is just 1. Okay. So moving over to the next page, we're going to look at multiplying fractions with mixed numbers. So with mixed numbers as well. The trick here, you have to change your mixed number into a top-heavy fraction. Okay, you have to change it into a top-heavy fraction. So you have to change this mixed number into top-heavy fraction first. So what would that be? 3, and this again is using yesterday's lesson. 3 times 1 is 3, plus 1 is 4 over the original 3, times by, this one is just a standard fraction, so we can just put that there, times by 2 fifths. We can multiply those across, where we get 4 times 2 is 8, and 3 times 5 is 15. Can we simplify that? No. Nothing goes into 8 and 15. Okay. Moving across. Same thing. You can have a go. You have to change, every time you see a mixed number, you need to change it into a top-heavy fraction. So we've got 1/3 times by, and this needs to be changed. So you can have a go changing that. So that would be 5 times 1 is 5, add the 2 is 7 over the original 5. And then we can multiply across, which would be 1 times 7 is 7, 3 times 5 is 15. And we cannot simplify 7 and 15 because 7 is a prime number. So again, you have an opportunity now to work through these. Where every time you see a mixed number, you're going to have to change it. Before you multiply using the multiply method, you're going to have to change it into a top-heavy fraction, an improper fraction, using the method learned in yesterday's lesson. So all of these things I'm highlighting in green need to be changed into a top-heavy fraction. If we look at the first one, we need to change this 1 and 1/2 into a top heavy, so we're going to do 2 times 1 is 2, plus 1 is 3, so this will become 3 over 2, times by 1/4, because that is okay. Now you can just use your method, where you times across. 3 times 1 is 3, 2 times 4 is 8. So the answer to that one is 3 over 8. Same with the next one. 1/4 is okay. This 1 and 1/2 needs to be changed, which we've just seen, but it is 2 times 1 is 2, plus 1 is 3. So that is 3 over the original 2. Now we can just multiply across. 1 times 3 is 3, 4 times 2 is 8. And as you can see, both of those are the same, just the opposite way round. So what that is just showing us is multiplication will give you the same answer if it's the opposite way round. It's what we call commutative. So 2 times 3 is 6, and 3 times 2 is 6. Even though they're the opposite way round, you get the same answer as 6. Okay, moving on to the next one. Same method. Every time you see a mixed number, you need to change it. So this will be 3 quarters times by changing this 1 1/2. Well, we've just seen that 1 1/2 goes to 3 over 2. Then you just times across. There is no opportunity here to cross cancel, so we just need to times across, and we'll get 3 times 3 is 9, 4 times 2 is 8. That is top heavy. Every time you get a top heavy improper fraction as your answer, I would like you to change it to mixed. And this is where fractions get very long, because you're constantly having to change between mixed and improper, which is why we spent a long time yesterday looking at how do we do that. So how many times does 8 go into 9? 1 whole 1 with 8 on the bottom, because that will always be the same. And what goes here, how many left over? If it's 1 whole 8, to get to 9 would be 1. Okay, so 2 1/2, 2 times 2 is 4, plus 1 is 5, so that would be 5 over 2, is what that would change into. Times by the original 3 quarters is okay, because it's not top heavy or mixed. Then you times across. 5 times 3 is 15, 2 times 4 is 8. Top heavy, how many times does 8 go into 15 whole? 1 whole 1 with 7 8s left over. Okay, and finally to finish these 4 off at the bottom, hopefully you managed to get onto these. 2 times 3 is 6, plus 1 is 7 over 3, times by 4/5, which is okay. So that top mixed number goes to this improper fraction. Times and across, 7 times 4 is 28, 3 times 5, yeah, I'm just times on top, bottom, is 15. How many times does 15 go into 28 whole? Well, 15 30 is too many, so 1 whole 1 with 13 over 15 left over. Next one. 3 times 4 is 12, plus 1 is 13 over 3, times by 4/5, timesing these across would give me 4 times 13, well 2 times 13 would be 26, double that again, would be 54, 52, sorry, over 15. That is top heavy. How are we going to change 52 over 15 into a mixed number? How many times does 15 go into 52? Well, 15, 30, 45, so 3 whole 1s. How do you get from 45 to 52? You have 7 left over, so it's going to be 3 whole 1s and 7 15s left over. On this last example, we are asked to change both of these now. So changing the first one, 3 times 4 is 12, plus 1 is 13 over 3, times by 5 times 1 is 5, plus 4 is 9 over 5, which is, now we have to times across, so we'll do 13 times 9, which is 117 over 15. Now that's quite a horrible looking fraction to turn into a mixed, but it's the same principle. How many times does 15 go into 117 whole? Well, you could write 15 times table out: 15, 30, 45, 60, 75, 90, 105, 120. 120 is too many, so it is 1, 2, 3, 4, 5, 6, 7 whole ones. With, how do I get from 105 to 117? That would be 12 15ths left over. Now this one, remember, you should always see if you can simplify. 12 15ths can be simplified, which would be 7. How many 3's go into 12 and how many 3's go into 15? Because that is the common factor, would be 4 over 5. So our final answer for that one would be 7 and 4 fifths. I'm looking at the next one, same thing. I'm just going to go a little bit faster now, so you're going to get 20. 1 over 5 times by 9 over 5. Here, if we times across, we're going to have 21 times 9, which is not very nice, but it's 189, over 25, which would be, how many 25s go into 185? Well, that would be, again, same method. You can write out a 25 times table, so you can say 25, 50, 75, 100, 125, 150, 175, 175, so that is 1, 2, 3, 4, 5, 6, 7 whole ones. How do you get from 175 to 189? Well, there's going to be 14 left over, 25, which cannot be simplified. Okay, so as you can see, this is using a lot of what we did yesterday, as well as the multiplying techniques we've just looked at. And as you can see, none of these questions really had any opportunity to cross-cancel. So we just had to use the original multiply and simplify method. So moving on now to the final part of this lesson, which will be dividing fractions. Dividing fractions involves, so you need to know, you need to be able to multiply. So that is why we started with multiplying. You should be able to multiply first, because there is a rule that tells us to divide fractions. You can remember this anagram. If you remember this, and this is what most students like to remember, KCF, whenever you see a divide with two fractions, think to yourself KCF. And what that means is keep, change, flip. Okay? Keep, change, flip. What does that mean? It means you keep the first fraction, you change the sign, and you change it from a divide to a times, and you flip the last fraction. So you're going to flip, which remember yesterday we spoke about the reciprocal. You're going to do the reciprocal, you're going to flip the last fraction. So if I do that, it's telling me I need to keep the first one, so that's 1/5, keep the first one. I need to change this divide into a times, and then I need to flip this fraction. So if I flip this fraction, it will become 3 over 1. Okay, now you know how to, you've just practiced how to times fractions together. You just do the top times the top and the bottom by the bottom. So if I do that, what do I get? 1 times 3 is 3, 5 times 1 is 5. So my final answer for this is 3/5. So we keep, change, divide 2 times, flip the last fraction. If you can remember KCF, keep, change, flip, these are very easy. And it just builds upon multiplying. So if you look at the next one, you can practice that. Keep, change, flip. So we're going to keep the first one, change the divide 2 times and flip the last one. Then it is nice and easy. Because multiplying is the easiest thing to do with fractions, you just times across. 1 times 3 is 3, 5 times 2 is 10, and we're done. So same thing, you've got some questions there to practice, using KCF, keep, change, flip. So for all of these I want you to just write out keep, change, flip, so keep, change, flip, and times across. So if I do the first one, keep, change, flip, and then times across, 3/4, that's your answer. So I will just go through these without talking so you can practice along. And if you're unsure, you can look up and see what I did. But I'm just going to fill these in now, and then we'll move on to the harder mixed number division. And if you get a top-heavy answer like this one, I would like you to change it into a mixed number. So 5/4 is top-heavy, so this would be 1 whole 1 with 1/4 left over. So keep, change, flip. Again, always try and simplify your answers, or if they're top heavy, change them into mixed. So keep, change, flip is all you need to remember. And just remember, when you multiply, you just multiply straight across. Here we can cross cancel. 2 goes into both of these, 2 goes into 4 twice, 6 goes into 2 goes into 6 3 times, which would be 1 times 3 is 3, 2 times 3 is 6, which simplifies to 1/3. Not 1/3, 1/2, sorry. So a little trick you can see with this one here, 3/6, we could simplify this before we start. What is 3/6? It's a half. So this is basically a half. Change, flip, and then we can see again, look, these diagonals can be cross-cancelled. 2 goes into 2 once, 2 goes into 4 twice, so we can do 1 times 2, which is 2. And 1 times 1 is 1. 2 over 1 just means 2. And finally, for the last one, keep, change, flip, times and across. 5 times 4 is 20, over 6 times 1 is 6. That is top heavy, improper, we need to change it to a mixed. How many times does 6 go into 20 whole? 6, 12, 18, 24. 24 is too many, so 3 whole ones. How do you get from 18 to 20? There is 2 left over 6. Which could be simplified to 3 and 1 third. Okay, so hopefully you got those answers, or you followed along. To finish, we will look at dividing fractions with mixed numbers. Same thing as multiplying, we're going to change these mixed numbers into top heavies first. So 3 times 2 is 6 plus 2 is 8 over 3. And then we need to change and then flip. Remember KCF. KCF, keep, change, flip. So that will be 5 over 1, which is 8 times 5 is 30, not 30, 40. 3 times 1 is 3. How many 3's go into 40? Well, it's going to be 13 whole, because 12 times 3, remember, is 36. Another one would be 39, so that would be 13, that's 12. So 13 whole ones with 1/3 left over. And then finally, for your turn, same thing. We've got a mixed number that needs changing. So 3 times 2 is 6, plus 2 is 8 over 3 again. Divided, so change and flip, which will give you 40 over 6, which we could simplify and change because it's top heavy into a mixed, which will be 20 over 3. How many 3's go into 20 whole? It's going to be 6 with 2/3 left over. Which leaves you with 4 questions to practice. Where you can use those same methods. Where whenever you've got a mixed number, you need to change it to a top heavy. So if we look at this one, you just have to be careful, that's 2/3. When we change this to be top heavy, remember 5 times 2 is 10, plus 1 is 11 over 5. And then we need to flip that because we're changing to a times and flipping 11 over 5, so that'd be 5 over 11. And then we're timesing, which is 10 over 33, which cannot be simplified. Here, when you've got 2 mixed numbers, my advice, is to change them first. Keep the divide in between. Don't try and flip it all at once. Change them first. So 3 times 2 is 6. Plus 2 is 8 over 3. 5 times 2 is 10. Plus 1 is 11 over 5. And then what we're going to do is keep, change, flip. So we're going to keep 8/3, change to a times, and flip 5 over 11. Timesing that across, we'll get 40 over 33. That is top heavy. We can change that to a mixed number. 33 goes into 40 once, with 7 over 33 left over. And you can repeat those same methods for both of these. So changing those will give you 5 over 3 divided by 11 over 5. This would be, and then you need to do the KCF on that, and this one would be 8/3 and 6/5. So by doing the KCF on this, we're going to keep 5/3, change to a times, and flip, which is 25 over 33. And that's your final answer for that. This one we're going to keep 8/3 times 5, 6, which gives you 40 over 18. That is top heavy and can be simplified. So if we simplify this, we would get 20 over 9. And 9 would go into 20 2 whole times, with 2 over 9 left over. Okay, so that concludes the lesson on multiplying and dividing with standard fractions and mixed numbers. Apologies, I saw in the comments about it echoing and reloading occasionally. Hopefully it wasn't too bad. I realised halfway through why it was echoing, but hopefully it managed to sort itself out at the end. The final lesson on fractions 3, will be adding and subtracting fractions. So hopefully you managed to follow along there and give it a go. The starter for the next lesson will have some of these examples in there for you to practice, and we will do adding and subtracting where most students struggle. Okay, thank you for tuning in, and I'll see you in the next one.